All right, y'all. So I'm obviously not here today, but we still got stuff to do. So you guys are going to be doing this worksheet today, and we're going to be talking about exponents and how we solve for them when we already have a base. And this is something from Algebra 1. This is going to be our review day, and then we're going to add things to it throughout the week when I come back. So let's take a look at number 1. It's a solve for x, and we have 80 to the 13x minus 8 power equals 80 to the 19x plus 6 power. So with these types of problems, I just want to keep in mind that we already know of a property where it says if we have a base with a value x and another base with a value of another kind, that means that we can actually get rid of these bases, and that is going to mean that x is equal to y. And with these ones, obviously there's a little bit more going on here, but the entire point is that our base must be the same for this to be true. We're basically getting rid of the bases once they're equal to each other and only keeping the exponents. So when we're doing a problem like number 1, my bases are already equal to each other. So when that happens, I can just drop those bases and I can copy down just what's in the exponents here and then solve that equation. So I could do minus 19x, and I would get 7x minus 8 equals 6, and then I would solve by adding 8, yada yada. 8 plus 6 is going to be a number 14. And then divide by 7, so then x will equal 2, right? We all know how to solve. I've seen your solving skills. It's just that now we got to think about our exponents and our bases, okay? So let's try another one. Let's do number 2. Okay, so we have 16 and 256. Okay, so these two do not have matching bases yet. I need to find what those are, okay? So I am going to have to use my calculator to do this, okay? Typically, when we look at these, you're going to want to change your larger base into the smaller one. And what I mean by that is I'm going to start with that smaller base and try and multiply it by itself until I get to whatever the larger number is here. So 16 times 16, I'm going to put that into my calculator. And that's going to equal, equals 256. Okay, so that's exactly what I wanted. All right, so what that means is that I can change that 256 to look like a 16. Now, I have two 16s that I used here, so I'm going to write that that's the same thing as 16 to the second power, okay? So what I'll do is trade out the 256 for 16 to the second power because they're equal to each other. So I'm going to have 16 to the 14x plus 6 power equals 16 to the second power. So again, I'm trading out that 256 for what I know it will be equal to, but I'm just using the same base as what I had here to get the problem to look the way I want it to. So now that my pieces look the same, I'm going to cross those out and drop my bases. I'm going to rewrite my exponents, and then I'm going to solve the problem. Okay, so minus 6, we would get negative 4 divided by 14 is going to be, let's see, negative 2 over 7. And that would be my answer. You could turn it into a decimal if you want to. I'm just going to leave it as a fraction, though, because that's not really what I'm after here. The main thing that I want you guys to practice is that changing of your bases. Okay, that's kind of the biggest thing that's going on here. So let's try another one. How about let's do one of these fraction ones. So This one, we are solving for z, again, just like x, just variable. And we are starting out with 1 over 64 to the 2z power equals 8. Okay, I'm just rewriting it so it's a little bit easier to see. But we're starting out with a fraction here. And we've already talked about this unit too. Whenever we see a fraction and I know that an exponent is involved, that's going to tell me that my exponent will be negative, okay? So really what I'm trying to change here is my 64, all right? Again, I'm starting out with my smaller base. That's going to be our 8. And I'm going to multiply 8 by itself until I get to 64. And luckily, that only took one try. So I would rewrite that as 8 to the second power. No, they are not all just going to be to the second power. You might have to go past that, okay? This is just how the example worked. But anyway, I know that, again, with my fraction answer here, that means that I'm going to have a -2 here instead. So I'm going to take out my 1 over 64, and I'm going to put in 8 to the -2 power. But I also can't forget all the stuff that was already behind that. So I'm going to include that in a pair of parentheses, like that. Equals 8. Okay, so if you already have pieces behind, you want to make sure to put those in parentheses. They don't get lost. We still need those. And if we see a fraction, that really just means that our exponent is going to be negative. And then I'm going to continue on with that process again. My bases are the same, so I'm no longer going to need those. I'm going to have -2 parentheses 2z equals, my invisible exponent here is going to be a 1. And then I'm going to continue on. I see that I need to distribute, so that's what I'm going to do. I got -2 times 2, that's going to be -4z equals 1. Divide by -4. I'm running into the next problem. It's okay. So then I'll have z equals -1 over 4. And that would be the answer to that question. Okay? So again, change your bases to match what you have. I'm going to trade out the piece that I don't want for the one that I do want. All right, so there are 3 of those done for you. Check them out, see how these work, jog some memories, okay? After this, you're going to go on to the notes. You only have 2 problems that you need to work on, and that's going to be on 6.6 part 1, okay? That's going to be this page here. Page 27. I would like for you to complete these questions, or question, it's only one, and then this question. Okay, they are done in the same fashion, but again, practice these guys first and then do those 2 last. All right, I hope you guys have a good rest of your day. Email me if you got questions, y'all. Bye.